Recording in
Yep.
progress.
So continuing to our class, as I said, we are learning about the AIOps and we'll do some labs today. Okay. Labs about Slack and Alert. Okay. Exactly at your real-time organization, the Slack alerts look like this whenever you go and you would like to implement. As I said in previous classes, how we are integrating this AIOps. Like you might be running as a Python job, Kubernetes job, cron job, any other thing. So most of the times your systems is already built with time series metrics from your Prometheus. So example, if this is this is your Kubernetes, then your system is already exposed with the Prometheus, okay, is already exposed with Prometheus, and then there would be a Grafana that will show you all your dashboards, right? So this is how it will be connected, and you will be having a dashboard. You will be having a dashboard here, right? So this dashboard will show all your metrics. This dashboard will show your all your metrics. Means whatever you're collecting from the pods, nodes, everything you'll be going to see it here, right? See it here on this dashboard. And if you take Slack, if you take Slack, okay, not the Slack or Teams or okay, maybe you have a system, maybe you have a system that you will get message in the Slack. Okay, you have a system that you get a message in your Slack saying that so there is anomaly detection happen, saying that this anomaly detection happen on what, and predictive analysis happen. Okay, that means in next 5 minutes your CPU of product product microservice may get down. So like this you will get some of the messages in the Slack. How does this really going to be worked? And root cause agentic things we will cover in the AI agents. If you see this predictive analysis, how it will be going to. So first you need to configure some Slack things. You need to, in your organization, you need to request your ITS team, like IT team, to get Slack webhook. Slack webhook. If you are in the Microsoft, you need to get Microsoft 365 webhook and some configurations. Then in your teams, you need to create a channel. In same, it is also same in the in your Slack as well. You need to create a channel. So go here, Slack login, type Slack login, login in with your account, login with your account. Okay, login with your account. Login with your account. Get into your workspace, use browser, and in the left side, you just see, here. So this is your workspace. So this is your workspace in the Slack. Okay. You can create a multiple channels here. So for our lab, we can create a channel called AIOps June batch, okay, or AIOps Anomaly or AIOps alerts, AIOps team, let's say. Alright. Public channel in your organization, you should create the private and no need of this. Only admin can view. Skip for now. I have right now this channel is created. I can invite you people, but it will be going to ask me to pay if I can't invite you people because it's a individual Slack right now. But at your company, it will be a enterprise Slack. So you will be having a separate dedicated IT team who is going to maintain this. But you can also invite the people, you can create the channels, you can do all the things. You can also create applications. In our AI agentic things, we are going to play with applications. So Slack is more flexible. Slack is used by many companies. Teams are also used, but I see that at more of companies are using Slack more than these teams. Yeah, teams also will be able to do everything, whatever you are doing with the Slack. The only thing you need to reach out to the admin team of the Microsoft 365 owners, and then you can request whatever you have. Here also it is same, but at some point you have a good permissions to do such things. Here I would like to get some of the alerts here. Some of the alerts here. How can I get that? See, I'm going to use a Kubernetes cluster. You can also create EKS cluster or you can also do in the killer coda. So since it is going to run some more than 1 hour of the lab or almost 40 minutes of the lab, so I would not recommending EKS because creating an EKS will take 15 minutes for us. There is no change. Whatever the repository is there, you just apply. It will be also creatable in the EKS. In killer coda also same, but in killer coda time limit is there. So that's why I'm using kind cluster, local cluster. Okay, kind cluster, local cluster I am using for now. Open your Docker desktop. Okay, open your Docker desktop and then you need to create kind cluster. The first step is you need to create kind cluster. And then I would like to install all related things about my lab. What I'm installing? I'm installing one web microservice or web app which is having some products. Which is having some products. Okay. It's like a JSON print only on the web base. I'm printing that one. Then to monitor this, to monitor and see the lab, the first one is anomaly detection. Second thing is predictive analysis. So these two things I'm going to do. So root cause RCA we will be going to do RCA1 we will be going to do in the uh, next agentic class because RCA agent should be there. So we are going to add one of our LLM and we will see this how RCA is going to be. It will give root cause analysis. So for this, it's a built on the synthetic monitoring only. Okay, the only thing you are just deploying some rules. For this, I'm using statistical analysis calculations only. So we can also use ML based filters, ML based models and all. It's up to us. If we have if we have logs, if we have traces, if we have metrics, you can go with tempo or open telemetry. Open telemetry. You can go with them and you can do the same thing. For now, to minimize and to make you understand, I'm using this only metrics from the Prometheus. So I have a repository here. You see, it's activating. What's the problem with this? Okay, let me update. Okay, it's already here. Fine. If you see this is our lab. Okay, this is our lab. So I was making this diagrams also for your understanding. For your understanding, I think it will only open in VS Code because I have integrated there, not even open cursor also. Okay. If you see this, the detection flow diagram, it's a JSON diagram is there. So I would be going to put in this website and then I will add it. You can find in my GitHub repository. I will give you in the classwork. So first thing, you need to install all these things. As we know from the starting of our classes, we are discussing the same. So first of all, we need to create a kind cluster. First of all, we need to create a kind cluster. Once we have kind cluster is created, then we can deploy our things. So meanwhile, let me explain you here. So this is about the cluster. This is the cluster configuration. And if you come here, so there is a server.py where I have mobile phone, category, electronics, price, some products only. It is just a normal Python script which is going to print on the web page. That's it. Just it is going to show in the JSON format. These things. So consider this is our application. In this place, you can keep your complete microservice. And then we have labs. In this labs, I have lab 1. In this lab 1, I have created scripts. The first one is creating the namespace. Second one is for product store config map, that we are sending all this into a config map, and product store deployment.yml, because I would like to run this as the pods, right? And service product store CPU alert configuration. So this is important. CPU alert configuration. I'm running a Prometheus rule. You can also do with Helm chart, but Helm chart will throw you an error. That's why I've written this YML file. Prometheus rule. So which is a monitoring namespace, which is a monitoring namespace. In the groups, which is product store anomaly rules. Here is the rule. So this is a promql query. So this is a promql query. What it is doing? Sum by a pod, qpod container resource request in AIOps namespace for the pod product store, any pods of the product store, for the container product store. What is the CPU? The CPU core. If it is the condition more than 75, then it is an anomaly. That means unusual pattern. That means it is unusual pattern. So this is the thing that we write in this kind of rules only. This kind of rules only. And then I have a Grafana dashboard, which I have said config map and labels Grafana dashboard. Here only I'm telling that Grafana dashboard, this one. So there are two ways to create the Grafana dashboard, from your declarative way and directly from the Grafana dashboard side. We seen last time in our class, I have took one ID and just uploaded over there. It created a dashboard, right? So like that. But in your real time, we will pass in YAML from your Terraform. From your Terraform, we will pass all these dashboard configurations, not from the Kubernetes cluster configurations. And I have monitoring values.templates. What I'm doing here, for my Grafana, admin123 is a password. And I created alert managers in my Grafana for alerts, for Slack notification. You no need to worry this how this template came. Just go and see this template. This template is already defined by the Grafana. I use the same template from the Grafana and I use this alert manager. Then I grouped by alert name, namespace and pod. So it is going to be a Slack notification as a contact point. As a contact point. In order to send that alert, it need a Slack webhook URL and Slack channel. Okay, now I got some understanding on these files. If you thoroughly go through one more time on this file, so this file is very simple. If whenever you wanted to create any alert, you have two ways to do. One is from Grafana dashboard, one is from YAML. You're directly creating this YAML file and you're provisioning it. Two ways. Two ways we can do. So this particular YAML, it available in Grafana or Prometheus documentation. If I go to the Grafana Slack notification YAML, whenever you wanted to work on something, see, we can use directly this template in where alert.yml, alert.yml, or you can also configure navigate to alert, IRM, alerting, notification configuration, contact points, add a contact point, select Slack, Slack API token, receptionist. You just need to follow. I do the same. I do the same. I will be going and reading this document because they have a clear instructions here. How to use Slack API token, webhook URL. Okay, go here. How to create a webhook URL here, incoming webhook. If you see it here, creating incoming webhook. First of all, we need to go to Slack apps, Slack app and create an app. Slack app, create an app and then enable incoming webhook. Activating webhook. Then create an incoming webhook by adding new to the workspace. Whenever you're done, it will create an application like this. Then you can select a channel here. Then your URL will come like this. I did the same, but I'm making very concise for this lab. Okay, I will be reading the same documents only. Now, if we go to our lab to the readme, to the readme, to the readme, the same setup. Open Slack API apps, create new app from scratch option. This is what I have added. It's not there in the document. Then you can create any name like this. Then workspace. Then incoming webhooks. Activate it. Add new one. And then allow. You will have the URL. You will have the URL. You can follow the same steps. You can follow the same steps. Okay. Let me check whether my cluster is ready or not first. Cluster is ready. Okay. Control plane, worker node 1 and worker node 2. Then I have to go to Slack API apps. Slack API apps. Come to Slack API apps. Slack API apps. So here you can see I have Slack API apps. You can create new app. Where it is? Create app. Create new app from scratch. What is the name of the our app? Um, look, okay, let's follow the same thing only. AIOps alerts, Kubernetes alerts, okay. And which workspace? My workspace. Create app. I created the app now. I created the app now. And what it said? It said that go to enable incoming webhook and create incoming webhook. Incoming webhooks here. Enable it. Yes. And add new webhook. Add new webhook. I've added. Now it is asking me which channel you want to. Which channel? AIOps team we created, right? AIOps team we created. I would like to get all the notification into this channel. Allow it. The moment when you do, you see added an integration of AIOps Kubernetes alerts and left side this app is added, you can see. AIOps Kubernetes alerts is added this side app. In your company also, if you are using, just go and see. There are multiple apps will be available. And I will be tell you how to add a bot, Slack bot also in our agentic things. A bot will do a lot of things for you. Slack bot. So this is how we can add. Now the integration is done. How does my Kubernetes will know that I have to send these notifications? So actually these notifications are coming from your Grafana. How it's coming from Grafana? Because because we have the file, right? We have the file. We have the file, this file, Slack webhook URL and Slack channel. These things I'm going to give it from my environment variable. So in your organizations, we will be going to use from Vault. We'll be going to use from these things from a Vault. But here, so no Vault system. So again, deploying a Vault, putting over there, calling here, it will be very difficult for us in the this kind of demo sessions. It will be need a lot of time to integrate. It will throw an errors to us. So in your company, it will be have one 2 3 days or 1 week of 2 sprints of time people will be spending on it, and then they will be enabling it. That is okay. If we have spent also, we can able to enable it anything if we provide some time. The only thing, in order to understand how these alerts can be triggered or the Slack of whatever we discussed in our last class. Now I have some scripts. These scripts you can use for traffic. You can use send the traffic. If I come to readme, I need to run this command. I need to run this command. Okay. So let me run this one. Our channel name is AIOps team, right? AIOps teams only. AIOps team, right? And this one I would like to. I would like to go to this one. Here I need to copy this. I have added, right? I need to copy this. Okay. Then come here. Paste here. Paste here. And okay, it's not went here. Yeah. Just copy this. Come to IntelliJ and what? Deploy it. So here script deploy lab.sh. So it is going to call like our last lab only in the scripts deploy.sh. Scripts deploy lab.sh. Same Slack URL is silent here. We are overriding this one, and release name is Kubernetes stack. Monitoring is a namespace, and then it is going to apply the same commands. Helm Prometheus, yes. Kubectl apply, rollout, all these things it will run the same thing. Now it is installing monitoring namespace. It's created. It is installing this Grafana and Prometheus with this Helm command. With this Helm command. That's why we discussed piece by piece in our Kubernetes class how this Helm to be, and in our first class also we manually deployed everything. Let us install. Oh, it got installed already. You can see now it got installed now. And now what I'll be doing is I'll do one thing. I'll just keep this terminal into uh, left bottom like this, and then I'll use this one. Okay, so once I have done, now you can check with these commands that these things are there or not. All things are running. Alert manager is running, stack is running, Grafana operator is running, node exporter, just single Helm thing only. So it is running, and product store also is running. Product store also running. Now I would like to expose product store and as well as Grafana. Just copy this and run this one. I think we need to maintain a multiple terminals now. So if I open this one, if I open this one, my Grafana will be open. Admin, admin, admin 123 is the password, right? We given. So AI also enabled in Grafana right now. If you see left side dashboards, AIOps product store dashboard has created available product store pods and product store CPU against request. Okay, let's keep for 5 seconds and let's keep for 5 minutes or 15 minutes. 5 minutes is enough. Now you can see this is what the usage is. This is what the usage is. Now I would like to see the products. I would like to see the products. Come here and see, this is our service. 7 products are there, like mobile phone, electronic category, price is this much. IDs to pen, stationery, price is this much. Keyboard, electronics, price is this much. So like this, you can treat like an API or you can treat like a web service. This is okay, casual. So treat this as a microservice which is having all products in this service. Now I would like to send a traffic to it. I would like to send a traffic to it. When I am sending some traffic, I can monitor the live things here. I can monitor the live things here, and then I can see some alerts in my Slack. Can see some alerts in my Slack. Left side, if you see, we even have alert rules. We even have alert rules. See, alert rules are there from our YML. Everything is automatically picked up. If you want to configure new alert, you can come, you can select Prometheus as a default. Here you can see you can run some query, the same query what we are doing. Run the query, add folder or label, set behavior 1 minute, configuration notification where you want Slack or where, we will be providing here, and then what message you would like to configure, you can type like this and save it. But this is the feasible? No. We will be running through the YML only. That is feasible. You are doing a manual changes at the Grafana. There is no state management. So state management should be there. There should be some record. This configuration somewhere should be recorded. Where? From your GitHub. How? From YML. You cannot do manual things. Okay, in development environments, okay, fine, you can do, but it's not recommendable. So anyone wants to see or copy your alert rule, it will be very difficult to see this dashboard and all. It will be very easy when you have YML. So that is the thing. If I come to the dashboard and this dashboard, now you can see the current usage. Now you can see current usage in the 5 minutes. Now what I will be doing, I would like to send some traffic, normal traffic. I would like to send some traffic. Let's take this one and let's send some traffic. So before sending any traffic, let's see our Slack. Let's see our Slack. Already got, already some firings are got. Here you can see in AIOps team, 8:38 p.m. because it is running already. Now let's increase some more traffic. If you see here, Grafana, where is Grafana? See, CPU against request, zigzag it is going. So when it is above the 0.75 threshold, it will tell you, hey, there is something happen. There is something happen. Now what is the time? 8:45. So off of more alert managed instance within the clusters are crash looping. 100% of okay. 5 times description. You might inhibit alert. This alert ensure alerting pipeline. Okay, you will be getting the new alert now. Let's see. It increased 0.516 on average. It's increased 57. Is this load completed? Load completed. So this is a normal load. Now let's trigger the CPU load. Trigger the CPU load. Now we are triggering the CPU load. When we are triggering the CPU load, it has to increase, and immediately you need to receive some alerts. Increased. Yes, red color. More than 95, you can see 97. Immediately it has to send here anomalies happen, like it is going to detect to you. The unusual pattern is happening right now. Unusual pattern. This is an unusual pattern. 170. Unusual pattern. Okay. It's an unusual pattern. 90 seconds. It is running right now continuously. Yes. Now you come here. You got it. You got it. Warning, one more target is unreachable. Okay. One more target is unreachable. So 291 CPU is triggered. 291 CPU is triggered. You got an alert that target down. So target down means from your Prometheus. Okay. Severity is a warning. The firing is happened. Severity is warning. If you come in the left side, alerts. Alert rules only. Uh, Alerts. Maybe we can expose Prometheus as well. Prometheus, yes. And we can check alerts over there as well. Alerts. Firing alert. Firing alert. Cluster down. Crash loop backing. So these are all the alerts. Okay. Now if you come here and see, now you got product store CPU anomaly. It's at the product level. Saying that service is a product service. Product store pod CPU anomaly detected. Unusual pattern happened. The pod product store to RVVG is using more than 75% of the its requested CPU for 2 minutes. That is a condition. This is usually means the traffic or application work is higher than the normal baseline. Normal baseline. It's telling you that unusual pattern happened. Unusual pattern happened. So when this unusual pattern happen from your files, from your files, there is this. See here, I said that rate container CPU uses seconds in the total. Namespace is this much. Product store is the pod. After that we have IDs. Container is product store. For 2 minutes you can gather the information. For 2 minutes you can gather the information. And then one more sum by both sum. It is a statistics. Core CPU core usage 0.75 for 2 minutes. Then give a warning as a anomaly detection and write your description. This is what I have said. Write your description. Yes, we got an anomaly detected. Successfully ran. Successfully ran. It is completed also. We got alert. If we run predictive analysis in the similar pattern, if we run predictive analysis in a similar pattern, how it will be going to show? It will be also going to show in the same way that predictive, like before in 5 minutes, something going to be happen like this. Now let me close lab 01. Let me open lab 02 product store predict URL. Only the one rule we are going to deploy. That's it. We are only deploying the Prometheus rule. Again, what I'm telling, sum by the pod in linear way. Linear means in continuous line, right? It linear means continuous line prediction. Linear. So if it is going like that, if it is going like that, the same query, AIOps is a lab of namespace, product store, product store. You see, product store. This is ID. Anything. The pod could be anything. You need to gather the information of product store. That is wildcard here. container, product store container for 2 minutes. For 2 minutes. Similar way for container CPU. If it is if it is 300 seconds, that means 5 minutes. More than 0.75 for the 2 minutes of things in 300 seconds. Then give a warning. Predictive analysis. The product store CPU is predicted across the anomaly thresholds. So based on the last 10 minutes of CPU behavior, it likely to be an incident. Likely to be an incident. So this is what the description that we are giving. So what we are doing, sir? Nothing. We are only keeping this query. We are only keeping this query in a rule. So in this query, you can use jet scoring also. Like last time we used Python. Jet scoring, ML based, isolation, random forest, SV, any models you can use. Write a small code, Python code for jet scoring. Again, it is going to run the same PromQL query only. It's not a big deal. Same PromQL query only. But we are giving a contact point to this Slack. Giving a contact point to this Slack to do this. If I go to README, how should I run the lab 2? Similar way, we have already configured these things. So no need of again doing this thing. But we can deploy this rule. We need to deploy a rule one more time. So copy this, come here and deploy this rule. Deploy this rule. Okay. Rule got deployed. As I said, predict linear. Predict linear. Now we can send some traffic again. We can send some traffic. So I'll come here. Maybe I'll take one more and then I'll send some traffic. Okay. Prometheus missing rule evaluation. Okay, this is different. So evaluation need to be done on these rules. Now if I go to here, I should see again the load in different pattern. I can see load in the different pattern. It increased. Okay. See the red color came. Unusual things have happened. Immediately you should see one message here. Yeah, you got it. It's from the Prometheus only. This is general alerts, general firings, critical. Your Kubernetes Prometheus stack etcd was insufficient number of members. So these things will also come. Like see, there are many alerts will come. Which one you need to prioritize? But right now this is not a problem. But if you are considering this and putting your bandwidth and going and doing your things, no, right? So that's why what we need? We need RCA. We will come predictive analysis also. It will combine all the firings in one combination and tells you which one happened, which is causing your incident, which is your causing incident. That's why we need RCA model, root cause analysis model. We can do with our LLM. The moment when you have an alert kind this like this, immediately your LLM engine will be triggered and it will give you all the information of what happened behind this. It will pull logs, everything, then it will tell you like how the chat GPT is printing solution for us. Similar way in your Slack, your LLM will work giving this is the issue, this is happened, this is the log, you should do this. So that is will come in our AIOps. Now you can see etcd member down. Okay, ignore this. You should get see things are increased like this. You should get one more one, which is predictive analysis one. Yep, you got it. It is rejection again. This is from the Prometheus only. This from the Prometheus is only. Target up, 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 down. Scraping get refused, refused, refused. Okay, these are causing the alerts. Okay, info bidder. You see, I didn't see. So firing on the warning. Product store is a service. Product store is a service. Now it's it will be resolve the things. So product store CPU is predicted to cross anomaly threshold based on the last 10 minutes of CPU behavior. Pod, pod, this one, pod, product store, this one, may cross 75% of requested CPU in next 5 minutes. Next 5 minutes. So it's a predictive analysis. This insight here it came. So we can prioritize this one. Oh, what happened? If this is going to be happen on your main microservices, if you are on a Flipkart, Big Billion Day, Amazon, those time they will be having like this. So if it immediately happens on demand, it has to be increased like with HPA and autoscaler. If those things also there still, you will get this kind of things, alerts. So predictive analysis, you might take some action on critical systems. We can enable predictive analysis things. On critical systems, we can enable predictive analysis things. This is how these two things will work. This is AIOps. AIOps means again where I'm using AI, sir. You can use here in the rules that running a ML based filters. See, it is resolved. Green. Why this much late it given, sir? Because we kept 5 minutes. We kept some 10 minutes of time, right? That's why it's for 10 minutes it's given this. If you keep for 1 minute only, immediately tuck 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 it will give you. Your Slack will be every time give a sound to you, or your Pegger duty or Ops Genie, Signal FX. There are many tools are there. So these tools will continuously hit alerts on your mobile. On your mobile. Now it is resolved. When you see the red color, so that's the problem, and now it is resolved because it got down. Okay, so if you are reading and thinking like, oh, it is given some analysis, but you should see the status first. Resolved means you no need to worry about it. No need to worry about it. Now when I have like this multiple alerts, how can I control this? This is called noise control mechanism. Noise control strategies. Yes, my engineering team is there, my SRE team is there, observability team is there. We made some good things. Yes, we used AIOps or maybe synthetic monitoring, whatever. But there are multiple alerts in a day. Within an hour, there are 100 alerts hitting on my Slack channel. Will you able to see those 100 alerts? No, you cannot. So that's why you need to have a noise control agent, or you need to do a noise control manually, that which alert you should prioritize and which alert you should not be. If you have 10 alerts, if you have 10 alerts, among the 10 alerts, immediately you should concise them and give single alert and give single alert. How it can be happen? You can again use a model, use an LLM to do that. But there's a problem and advantage also. The problem is, yes, that may not be work 100% right. Maybe because of that, you might miss the main alert. The main alert. Instead that you can use RCA agent. Can use RCA agent. So RCA agent will tell you that which one you should prioritize. Which one you should prioritize. Otherwise, you can also collect all these alerts in one go. Then you can trigger one more workflow that correlating all these alerts and only prioritizing few things, like maybe this is critical, it is showing critical means critical thing only it has to show here. So this kind of nice control work you have to do. This is your work as an AIOps. You have logs, traces, metrics. Now we are only using metrics. What if you are using open telemetry with all traces and metrics and logs? You should control. You should control this thing. So that's why noise control engineering is a separate job. Again, job in the sense not the profile. It's your part of your job, but you will be working on this like 3 sprints, 4 sprints, maybe a 10 sprints also, maybe 6 months also. If it is a big system like T-Mobile companies. If you see the T-Mobile, a company, the vast products, Dutch, vast products, big data centers, very big applications are there, different departments are there. Okay, so to handle them and going and seeing which team is owning which alert, you need to route. Alert routing also is important. Alert routing also need to be configured. So where, how? So this is the engineering comes into the AI ops and observability. I'm only giving you the glance, guys, because we are not the production system to show all the things. But I'm giving you this knowledge that these are the real-time things. If anyone working in an SRE, please mention here. Are you doing the same thing what I'm explaining? Okay. So this is the your stacks and interfaces will look like, and you can practice this one. I'll be giving this GitHub repository. You can use the same repository and you can run this. And for each thing, I have given a very clear explanation why I am using it, why this method I have used. for what I have used, and each file I have used I have written also. For this file, detection, CPU spike, slack alert, and predict linear things. For each file I have added an explanation. Please read it first and then execute this lab. And please fork this repository, give the stars, and then fork this repository into your GitHub account and do the practice. If we have any issues, just ping in our Telegram or ping in our my WhatsApp on my WhatsApp. Okay. So if you go through this, I would like to start agents, because from agentic point of view, we again will come to the same Kubernetes RCA things, SRE agents, these things, MCP connectings, okay, tool connecting. We will come to the same point. So we will start with an agents, open source agents and cloud native, Bedrock and ADK, the Google, okay, and we will learn more about the agents. Then we'll do some of the labs, so that you will have a very clear picture and I can drive on your interviews, questions and answers, how you should talk. And like in early morning, I was teaching one more batch. In that batch, one of the person got into an EPAM, is likely going to release an offer. So EPAM is a very strict interviews, 1.5 hour, 1.5 hour. Yeah, so he cracked it. So completely, it is in completely LLMs. So yeah, things like that, and it is a very good start. If you keep reading these things, what are the notes I'm giving, and as of now, whatever the knowledge you have, it's a good thing. And one more student from my last batch, he's already working as in DevOps, but he got already an AI powered automation engineer. Now, he shared something yesterday in the night. He is developing an agents with the cloud Anthropic. Okay, he is extensively using those things, and his company is asking to get the certification of Anthropic. They're paying for it as well. So, but there are free also there, and there are paid also there in terms of cloud AI powered automation tools to be used. There are multiple AI powered automations tools to use. So I was asking like, how do I integrate? How do I do this, that, this? So there are big scope for him. A very, 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 I'm jealous about him. That kind of platform we never get. If you are getting that platform, you are very lucky to integrate those tools. Windsurf, Codex. That is what I'm going to start the course in next maybe in 20 days, 25 days. AI-powered automation tools. So whatever the tools are there in the market, we can use those tools and we can automate the work, not to be manual. Automate it. Simple. So even you have a big infrastructure, you can do automate. I also keep telling you that maybe you can try AWS DevOps agent also. Try stud agents also, I will tell you. So that is a very good approach to try AWS DevOps agent. Maybe your company is on the AWS DevOps. You can use that agent. Very good product. When we have an agentic class understanding, eventually you will be more interested how these agents will be working, because we have already good understanding on the LLMs, right? How the LLMs can be worked. And then I will be preparing your profiles, like how you should prepare your profiles and which you need to add accordingly, how you should speak out confidently in front of the interviewers, so that they can believe you that what you have done. So you can showcase your labs also. You can put in on a paper, write down in a paper what project you need to explain, how you should explain, what the follow-ups they might going to ask you, how you should tackle. All those things I will be sharing after agentic classes. Okay, cool. Any questions as of now? So this is about this two labs. You can go to my GitHub and then you can find. I'll be adding this link or this repository over there in our classroom. Any questions?
One question I have, Rajni.
Yeah,
Can you go to that YAML predictive rule YAML?
yeah,
So here, I think you have used the rule, right?
yes,
And um in production or maybe in different environment, we might end up using machine learning models for that as well, right?
yeah,
Extracting the data from Prometheus and then sending it towards the model to predict.
yep. As I said yesterday, we can write a Kubernetes job where your model will be working in it, like in a batch process. Example, for every
Hmm.
5 minutes you can use push gateway. Okay,
Okay.
you can use push gateway. Maybe if you have push gateway, let me take. Have push gateway. So all your custom things, custom metrics, if you have for specific to applications, use it from the push gateway and run one cron job. One cron job. Okay. Run one cron job. So in your Kubernetes only. Okay. So this one, in your cron job, you will be having your Python script with a model. Python script with a Python ML model. ML model where it will be? You will be loading from S3 again. The model job lib model or whatever there. In your S3 it is there. Okay. Example, you have the model here that you already loaded into the script. You already loaded into the script. Then it will work here. So this model should be trained right first. This ML model should be trained right.
Right.
So for this, we will be running. You can use any Airflow DAG. Okay, Airflow DAG. Maybe your GitHub Actions also. Collect a 30 days of 30 days of logs or some data and train this your model and build your model, evaluate on your model and put it here. From here you can load into this Python cron job or Kubernetes job. So this is one way. One more way is like I cannot use this one. I can use directly a deployment set. Can use a deployment set. I will run this ML model as a API. API. API predict. Okay. So from this push gateway, if I was loading as a pod only. This pod is nothing but my API, predict API. Okay, Python API only. So from my push gateway, all these metrics are coming, right? So I can write all the logics into my API that it will hit this predict thing. So whenever it predicts is true, give a notification.
Okay.
Give a notification. This is another way to do. Like this, we can run ML models like this. So LLMs. In this case, if you wanted to use LLM, you will be end up of paying to the LLMs because the tokens are more, right? Tokens are not is not cheap. It's costly now. Log will be heavy. In just 5 minutes, you will generate lot of logs. Understanding 5 minutes log, it will be a 2-3 pages, right? Metrics also big pages. So that much log if you are giving to the LLM, your input tokens only is going to eat your money. Your output tokens also going to eat your money. No. Is there any other way? You can use in-house LLMs like Llama. You can use in-house LLMs. Maybe you can deploy your in-house LLMs and you can configure here in this case, in this predict case. In this predict case you can. But latency is a matter. You need immediate alert. You need immediate alert. If you are tweaking and working on this, it's your win. If you are dealing with this latency, it's your win. So it is more good, more concise, more trained process if you use LLM, in-house LLMs. This is way how I should place my AI into the system.
Okay.
So you can
So Rajni,
yeah,
but the logs, right? But logs is not the structured data, right?
yep.
But again, you have to spend some time to clean up or pre-processing this data, right? What do you call it as EDA, right? That will take a lot of time,
No,
right?
no, 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 no,
So
no, 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 no.
mm.
See, so time series is always a time series data that is not things like every time it will miss. It's a regular format. Logs. Logs are not again a text format only. Okay. You might be using a BERT model in your ML. Okay. Maybe you are using any other models in ML. You can use that in your in-house LLMs also. You can use that. So logs can be understandable, and this metrics also can be traces also can be. It's a regular format only. It is not like our text, right? Natural language. We whenever we give, we write in a different angles. But these logs are in a
That that will be a normal our NLP, isn't it?
race. So this is different and this is different. This is comes into a regular format. So when you're coming to this regular format, there's a case also. The case is like sometimes your CPU will be showing 0.6.21. What should I understand from this? That means 0.6 is the consumption of my CPU. What if my model will be understanding in different angle? It should understand in different angle, right? You should test this one before you're going to this. You should test. You should convert this metrics if it is needed. You should convert these things, maybe like 65 percentage or 60 percentage, right? 0.6 means 60 percentage it is using. Does this value it is needed or does this value is needed? You need to evaluate this. If a model is okay to understand this one or okay to understand this one, how it is. So in these cases you need some sort of data cleaning that we call data cleansing. And then again, push gateway side we are putting the new features, right? New features means feature engineering. We have 1, 2, 3, 4 features. By using these 4 features, I will generate one average feature, right? XYZ. So that is our custom feature. In push gateway will give custom feature. So this custom feature will feed it to the ML model. Feed it to the ML model. But at the AIOps side, you will be not doing that much cleansing, sir. Cleaning, cleansing, or whatever, or feature things. You might be writing some custom metrics and you are loading it one model, and ultimately you are running some Python scripts over there with the same PromQL query. So most of the cases, your PromQL queries can solve your issues. The only thing you need to feed into your model that learn this pattern from this PromQL or from this logs, learn this pattern and predict the probability. Probability is 0.1, okay, or 1, confidence is 1, then true. That's it. Then trigger an alert. This is how you can do AIOps. If you explain this exactly what I have put on the board, that's it. No one will not going to ask any follow-up question in your interview.
Yeah. So, Rajani, one more question. Sorry, I'm not understanding it.
Mhm.
So, let's say the logs, right? So, you have the logs, right? Using that logs, you are going to train the model to understand or identify whether it's anomaly detection or not, right? But
Mhm.
the logs is not the structured document, right? It's
Mhm.
kind of an unstructured only, right? So, what you are saying is you send these logs to LLM and then directly ask for whether it's anomaly detection or not, right? Or my question is, how do you train that model based on the logs?
Sir, yeah, so that is one. You have two things, okay? Logs are unstructured as you said. In logs, you can use might be a but, right? So but on the text things most of the times. You can directly feed your things here and you can train your BERT model. Am I right, sir? BERT model or distill BERT
Mm,
models. Okay. Or you might be doing classification, or do you want to do any uh, keyword skin like DB scan? Okay. What happens? All these logs will be categorized into this one, this one, this one, this one, and then you can calculate your metrics and see whether it is right or not. Before that, you need to know the issue. From these logs, this could be an issue, so that you can able to validate this metrics. If you're using this a DB scan or this like this, you can train your model on top of these logs. Once you evaluate it, you can load the model into your API or cron job.
okay.
Okay. Now coming to the metrics or traces. This is the regular format. So this regular format you can use for your isolation forest models, ML algorithm or random regression. You can use for that, it will be working. So when I need this converting these units, uh, maybe I have to do some feature engineering. So no need of feature engineering on this because we already do the custom things here. Do I need to do like in MLOps? I'm doing feature engineering on the data. So this is a regular data, sir. So we don't need that much feature engineering here. Sometimes, maybe you are collecting from the different sources. You wanted to do a correlation between. You want to do a correlation between. So there are some other techniques. Okay. So you can do that in the Python, and then you have to find out for specific application metrics. It's only for your specific application only. You wanted to go with specific application to find out the specific correlation IDs, and then you have to trigger an alert. So in that case, you can come up with other techniques. So, but before that, these things are enough because this is give you more insights about your system. Getting so?
Yes, Rajin, thank you so much.
Yeah. If you have any specific thing, please ask me, sir. Any questions?
Um, no, I need to practice it and then I'll let you know.
Yeah, yeah. Any other questions from others? No? Okay. So there might be again incident triggerings, and whenever okay incident or whenever any alert happen, we need to trigger our LLM as an RCA analyzer, okay, root cause analyzer, and RCS, root cause solution provider also. So we can do even chat as well. What I need to do to continue and follow up things, we can do chat as well with our LLM in this system. In this system, we can practice that Until then, just please do your practice so that your hands will get dirty, you will get more experience, you will have some more things to ask me questions. We are moving to the agent side, so I would be expecting the questions at the agent side because that is a hot topic now, hot skill also. In your resume, that should be must. Must. Agent should be a must skill you need to be added.
Rajni, one more point. When we will explain about this AIOps part,
Mhm.
so we should know about the anomaly detection, how the models are being trained on for the anomaly, or we can only focus on this ops part, that how ops part has been done.
So anomaly is simple, right, sir? Unusual pattern. Unusual pattern, you have three things. You can use ML model, you can use scoring things, or you can use statistics like PromQL queries. That's
Mhm.
it. We explain these three types. That's it. Other than this, there is no other options in this anomaly. So when somebody is asking, how do you going to do this? Yeah, I have all the metrics with me already. So with the metrics only, I will sum them and I'll take a mean out of it, like standard deviation. And then I'll got the result, score. If this score is true, that is an anomaly. Right, sir. That's it. That is an answer.
Okay.
So yeah, someone is asking like, oh, this is anomaly. You should explain. This is anomaly. And how?
Actually, I just simply take the anomaly example, but maybe if we are explaining predictive analysis, or
Hmm.
if we are telling about, let's say, uh, forecasting thing, let's say we mention, so we should know the details about that as well, right?
Yeah. So in predictive analysis or a forecasting or right sizing your capacity.
Mhm.
So right sizing your capacity or predictive analysis side, as I said, predict linear. Predict linear. That means this is X and this is Y. Data points are like this, right? Your this is will go like this. So when your value is like continuously going in linear, that means it is hitting some point where we have a threshold. That means it's also an anomaly. And before it is reaching this point, my predictive analysis is calculating around this area and telling me that in next 5 minutes, this is going to reach this point. And resource capacity also, similar way like that. You can use any ML model or an LLM model that understanding of this metrics, understanding of this metrics, you can write a PromQL query that from last 24 hours, from last 24 hours, 75% CPU got used, or last 24 hours only 15% is used, but and how much we allocated like 100% CPU, so we are wasting 75% of the CPU here. So we will take an average with the same PromQL, we will take an average of 3 months. So when we take an average of 3 months, from the 3 months it is using only 25%. So that means rest some 60 or 65% or 55% I can save. Why should I pay for it? I can save. So in that it will automatically give you an alert. So this is not regular. This will be done weekly basis. So this job you can run on weekly basis on some of your systems. In your Grafana board only you can see. Weekly basis, every 7 days if it is run, so you can plan for capacity right sizing or forecasting things. The same thing you can call as a forecasting. So forecasting again with the same logs, same metrics logs, you can give it to any ML model and say that predicting, predicting if it is using 75%, if it is using 75% From last 3 months, it is using 75%. That means in coming 2 months or 1 month, it will be increase up to 100%. That means we need to also right size. We need to increase it. So this is forecasting, that it will predicting a month ahead that it is likely going to be touch this point. Similar like linear only, but we are changing the names. Similar like linear only, like predictive only, but we call it as capacity forecasting. But here it is analysis. That is the only difference. We use again same this ML filters, the same PromQL queries, the same statistics deviations. Only thing in our Slack, in order to craft that answer in a human understanding way, maybe we use an LLM to craft that answer to us. That's it. It's in our hand. We can use LLM or not, but you can use this alert. Hope I answer your questions.
Yeah, I got it.
Yep. So please go and run this lab so that you will be having good understanding. And in README, we can clean this lab. The last I have added. Delete the cluster directly instead doing this. Gone. Deleted. Yeah. So that's all for today.